So now let's do a practice problem for one mean hypothesis t-test when we're given the sample statistics. A hospital is trying to cut down on emergency room wait times and believes the average wait time is below 2.25 hours. An investigation committee randomly surveys 85 patients. The sample mean was 2.5 hours with a sample standard deviation of 0.75 hours. At a 99% level of confidence, does the data support the belief that the average wait time is below 2.25 hours? Okay, this problem is a one mean t-test because there is no population standard deviation. There's just not one, and it's not given, and there's not one that says that it's known. So I'm not given one. So then that means I can answer D and say that there is none given or NA. So the reason I do that is I'm just trying to close the loop and show the stuff that we looked at Z-test is different for what we look like for t-test. Okay, population mean. Again, the population mean is the one that I'm testing in the hypothesis test. I'm going to put it as yellow. So this is going to be 2.25 hours. The sample mean, it's given. The sample mean is 2.5 hours. So I'm going to do this, 2.5 hours. Okay. Again, I don't have a population standard deviation. Sample standard deviation is given with 0.75 hours. Okay, that was easy. And then level of significance. I'm not given a level of significance, but I'm given a level of confidence. So 1 minus 0.99, again, I convert that percentage to a decimal, equals 0.01. Okay, so that's my level of significance. Sample size, 85 patients. So 85 patients. Okay. And then I can do the correct, null, and alternative hypothesis. Let me do this as HA. So, okay, it wants below 2.5 hours. Below is the same as less than or beneath. So there's no equal sign with it. So I know then that means that is going to be in my alternative. So this is going to be less than 2.25 hours. Okay. Again, it's my original claim. Right. So then what does that make my null? My null is going to be the mean is, because I'm using the less than there, it's going to be greater or equal to 2.25 hours. And that's not my original claim. Right? So now it wants me to do my t-test statistic. Well, that means I've got to go to Minitab. So I'm going to Minitab. I'm going to Stat, Basic Statistics, one sample T. I'm going to put in Summarize Data. So my sample size is 85. My sample mean, I'm going to go back and look, is 2.5. My standard deviation is 0.75. My hypothesized mean is 0.25. And I've got to click this to let it activate it. Again, sample size is 85. Sample mean is 2.5. The sample standard deviation is 0.75. Hypothesized mean is 2.25. Again, it helps if you keep everything straight. The biggest errors I see are when students flip the sample mean and the population mean. It'll give you some wonky stuff when you do that. So you want to make sure you know which is which. Again, population mean is what's in the hypothesis. Sample mean is what's coming from your sample that you're comparing to the population. So go back, go to options, 99 for this one, because remember I wanted a 99% level of confidence. And now the mean is going to be less than the hypothesized mean. Not greater than, not equal, less than. Hit OK and hit OK. And I'm given a lot of stuff. So see it here, I've already got my sample size, sample mean, and sample standard deviation. I don't need that again because it was already given to me. What I need is this down here, and I'm going to copy it. And we're going to put it on the document. So let's go down here and put it here. All right, So again, I'm going to compare my alternative with my alternative, and they look the exact same. So I'm doing something good. So t-value is 3.07. P-value is 0.999. All right. So 0.999 compared to 0.01. And again, if it's confusing to have only two decimals, add another decimal behind it. And look here, where did I get that? I got that right here from the level of significance, right? So I know this is greater than this. So that means because the p-value is greater than the level of significance, I fail to reject the null. Okay, what does that mean? It means the null is true, the alternative is false. So I go back up here and I put this is true and this is false. All right, so now when I start to make my conclusion, I know that my original claim is false. So I'm going to go back up here and do this, okay? I'm going to take this and copy it because I'm going to rework it to make it what I need. So I'm going to go down here. Okay, at the 99% level of confidence, that's how I want to start, and because that's how it was given to me in the problem. The data does not support the belief that the average wait time is below 2.25 hours. Why? Okay, remember, I'm going back up and explain it again. My alternative, which was my original claim, was found to be false. So I'm just saying that basically the alternative is false because the data didn't support the belief that it was below it. So what it really means is it's either equal to or above. So that's my conclusion. At the 99% level of confidence, the data does not support the belief that the average wait time is below 2.25 hours. And again, I could add the t-value and the p-value if I was writing a research paper to help close up that loop.